In this project, I'm going to demonstrate how we can use the NRF radios on the Idiotware shield to build two smart robot cars that will talk to each other using the radio modules. You will need the following things to get started: two Arduinos, two Idiotware shields, two I2C OLED displays, two pin jumper, 18 female jumper wires, 10 male-female jumper wires, 2 H-bridge motor drivers L293Ds, 4 DC motors, 2 robot chassis kit, 2 lithium polymer batteries of 7.4 volts, 2 HC SR04 ultrasonic modules, and 2 NRF24L01 radio modules. In the code of the Swarm robot application, we have to include a couple of libraries. These are the RF24 network, the RF24, the SPI library, and the U8glib library. The RF24 network and the RF24 libraries are used for NRF interfacing and mesh radio application. The SPI library is required by the mesh radio because it interfaces with the Arduino on the SPI bus. The U8glib library is required for the OLED display. The CE and the CSN pins of the NRF radio are connected to pin number 7 and 8 of the Arduino. The radio object is being passed to a network object here. This is the number of the node. The name of the other node is 1, which is the other robot. The message to send is a character array which is set to blank string right now. Notice that these all initializations we've covered in earlier videos. The motors, the left and the right, are actually pins that are connected on the motor. So the left motor is connected to pin number 2 and 3. The right motor is connected to pin number 4 and 5. The trigger pin is on 9. The echo pin is on 6. These two pins are related to the HCSR04 ultrasonic module. If you go below in the code, in the setup function, what we are doing is that we are setting the serial baud rate, the trigger pin, echo pin directions. We are setting the outputs of the motor to off. We are setting the font as U8G font unifont. Once we've done all that, we initialize the radio module. We initialize the radio module from SPI begin, radio.begin, network.begin, and we have to pass the address of this node. Here what we see is that it'll show you that this is the robot number 0. In the loop, there is a call called network.update. This has to be called within a specified duration within the loop function so that new messages received on the radio have been received by the Arduino. In this section of the code, you will see that it checks for if there is any obstruction within the range of the ultrasonic sensor. If it sees that, it prints out the distance. If the distance is less than 20, then it stops the motor, turns right, and then stops the motor again. This is then sent to the other robot. So the other robot now knows that robot number 1 has already found an obstruction. It takes an appropriate action. In a similar manner, if the current robot finds that there is no obstruction ahead of it, it's supposed to move forward, and it also tells the other robot that it is continuing to move forward. Once that is done, the other robot also takes an appropriate action. These are functions that have been created to abstract the actions of the motor stopping or moving forward or turning right. If you notice in the motor stop, all the pins of the motor are set to low. In the drive forward, they are set alternately to high and low. In the turn right, the left, the pin zeros or the array or the elements at 0 of the motor left and the motor right are set to high and low, and it's the inverse on the other two items in the array. So with this application you have seen how it is easier to use the Idiotware shield with all its interfacing options, the radio and the motor, to build your Swarm application.